This is the Martha Fox Heck Elementary School in Belgrade, Montana. Terry Goins is a first-grade teacher at the school. It's Monday morning. Miss Goins begins her class by reviewing a lesson she introduced last Friday.
Boys and girls, do you remember last week when we worked on these mathematics problems? Yeah. We named these. Will, do you remember?
Windows.
Windows, right.
Windows is a new activity designed to help students develop their ability in addition and subtraction.
Now we have a problem up on the board. How did we get that problem?
We tried to think of something, but we didn't all get the same.
That's right. How did we get these numbers out here, Sam? Do you remember that?
Me and Rachel, we knew that if 4 would equal 8, then we put those, and if 1 and 4 would equal 5, we put that there, and if we put 2 and 1, it would equal 3, and if it was 2 and 4, it would equal 6.
Okay. Were we adding? Is that what you call that? Mm-hmm. Yeah, we call that adding, don't we? Well, boys and girls, let's create a window together as a class. But I have one rule about putting tiles in these squares. You can put up to 7 tiles in these squares. That means you can put 7 or less, but you can't go over 7. Okay? Does anyone have a number of tiles that we could put in the first square right here at the top?
3.
3. Okay, here we go. All right, now, does anyone have a number we can put in this square right here?
1.
1. Okay, I'll put 1 in there. Does that follow the rule?
Yeah.
Yes? Okay, let's go down to the bottom. Does anyone have another number for down here?
6.
6. Okay, you help me count and make sure I get the right number.
2, 3, 4, 5, 6.
Did that follow our rule?
Yeah.
Rusty says no. Why not, Rusty?
3 plus 6 equals 9.
Okay, you were thinking about 2 squares. Good, I'm glad you brought that up. Rusty, I said that we couldn't have more than 7 in just 1 square. So it's okay. I'm glad you brought that up. We have 1 more square to fill up here.
5.
What do I do now?
You write in the numbers where the arrows are.
Or how do I get this number here?
With the tiles, you don't have to count them if you know the numbers, and then you can just put the number there, which that first number up there
Okay.
would be 4.
And it would be what?
It would equal 4.
4. So I'll put 4 right there. Okay. All right. Now what do I do?
You put the next number over on that side too.
Okay, in this row. I wonder what number I'll put there.
11.
How did you figure that out, Will?
I counted them in my head.
You counted these in your head and you came up with 11. Does everyone agree while I put 11 here?
Yeah.
Yeah? Okay. Now we've done the rows, let's do the columns, right? Okay, does anyone have any idea what I'll put down here at the bottom of column 1?
9.
9. How did you figure that out, Marcy?
Because Rusty said that it will equal 9.
Because Rusty said it would equal 9. Could you figure that out by yourself, do you suppose? How did Rusty get 9?
Probably counted.
He probably counted. How did you get it, Rusty?
3, 6, 9.
You counted by 3s. You went 3, 6, 9. Okay, so I can put 9 down here. Do I have anything else to do?
At the next
Okay, column 2. What number will I put at the bottom?
6.
6. How did you get that, Bradley?
Counted.
You counted them. Okay. 6. Do you think you could create a window at your desk? When you are done with creating your window, I have this recording sheet for you. And up at the top, it says group names, and you'll use the markers that you have at your desk to put your group names up here. Then I want you to write all the different solutions you can come up with if you took all of your tiles away and tried to get these numbers with different tiles. Are there any questions about what you'll do?
I don't get it.
Okay, Joe, I'm going to take these tiles off of here right now. then you come up with as many different ways to solve this problem, just like we did on the chalkboard. Does that help, Joe? Any other questions before we begin? Okay, go ahead and start creating your own windows.
Copy off the board.
You're going to what? This is a good lesson for the students because they can delve into their own particular thinking levels no matter where they're functioning, whether they're at the symbolic level or at the concrete level. Some of the students are able to do addition problems vertically and horizontally very easily and use the symbols, where other students need to use the tiles right on the mat, and they even get confused adding vertically and horizontally.
Once the students have finished finding solutions to the first problem, they are allowed to create their own window puzzles.
Good. Okay, so what number down there? And? Okay, good. Now, how about your recorder here, okay? Joe, you go ahead and record that on your sheet here. Do you want to turn that around so you can see it better? There. Joe, did he get the right answers here? They're all correct? Okay. Now, watch what we are going to do now. We're going to erase these, just the numbers inside the window. Now, can you find any different solutions from what you already have there? Ah, do you think you could do that? Boys and girls, after you have gotten one solution, take those tiles off and see if you can find some more solutions, as many solutions as you can find. Okay, go ahead and put however many you want. Today's lesson, the goal was whole number computation. They were doing addition, but to get the answer to the Windows problem, they also needed some subtraction. So I guess maybe the highlight is the student interest. They were intrigued by this. Okay, you got them? Okay, now put 5 and 3 over here. Put your names up here. And after you get your window created, you can put your first solution there. And take your tiles away and see if we can find another solution. How did you figure that out? Do you need to show me how you counted?
I want 5, 6, 7.
Okay. I need to have the students justify their answers because I need to see how they're thinking, how they're problem solving, what reasoning skills they're using. If they just come up with the answer, it doesn't tell anybody anything. We really need to know what's behind that answer. Okay, how did you figure that one out?
I want 3, 4, 5, 6, 7.
Okay. All right. Is that a different solution? Great. All right, Kale, can you copy Marcy's solution down here on your recording sheet there? You can cross that 2 out, okay? There you go. Okay, and how about here? Okay, was she correct? Is 5 plus 2 equal to 7? Okay. All right. Now go to the next one. Okay. So how many solutions have you found?
3.
Well, you found 3 already, haven't you? We might want to look at that middle one there. Check and see. Is that one correct? What's wrong with it, Mercy?
5 plus 4 doesn't equal 8.
It doesn't equal 8, does it? Ooh, that one might not be right. Might check that one, but see if you can come up with another solution. Okay, how did you think that went through, Christine?
Because I know that 4 plus 4 is 8.
Okay, all right, good. You've got column 1 done.
Okay.
Okay, all right. How did you think this went through, Christina?
Because I just know when you have 4 and you add 1 more, it's 5.
Okay, all right. Will, what do you think?
Good.
That's good, okay. Well, we've got 1 more square to fill. What do we need to put in there? Good, Well, how do you suppose she thought that went through?
She could have counted 4 on
4 there. And then 3 more at 7.
Is 7, okay.
And then going down this way, it equals 4.
And 1 plus 3 equals 4. Okay. Did you find a different solution? Okay. Can you record that one here? Okay. Boys and girls, let's come to a stopping place right now. Let's put everything down. Well, boys and girls, we're done for today. You know what I want you to do? Give yourself 3 pats back here. I saw really good thinking today. You did a nice job. My own mathematics has grown tremendously. I've taught for a long time. I've never been more excited about teaching the kids every single day. They teach me about mathematics and how they think about mathematics, and it's really exciting.
Discuss why some students used tiles and others used symbols. How could this lesson be extended to explore other mathematical concepts? Consider the role of puzzles in learning mathematics.